Hello, how's it going? I guess officially this video is being titled Static Geometry, but I would really call it resource lumping, resource grouping. We've got a mesh factory and we can tell it to load a file and it goes, there you go, there's the file. What I want to do is I want to have a sort of a workflow where I tell it to start listening to my input, and then I tell it to append a file, and I can append multiple files, and it will load them in and throw that data into the same buffer, and then I can tell it to actually go ahead and build that file. There are two really good use cases for bundling a whole bunch of models together into one sort of mega model. One case is with geometry. Things in the world which exist, but we never interact with them. We just view them. And so they're not going to change their positions or anything. We can just get them all together. So let's say we have tree, a wall, and whatever, some other things. It really doesn't matter. But we bundle them all together as if they were a single model, and then draw them in one draw call. This reduces the CPU overhead. It's an excellent strategy. And then the next approach we can do is, remember, we have animations. And currently, the animation is a vector of models, a whole bunch of individual models for each frame of the animation. But what we could do is, I don't know, I'm not a drawer, but load in every frame of the animation into a single mega buffer, mega model, and then depending on which frame we're after, just draw that region of the model. And so I think that's enough to get started. Let's have a look at the code. All right, so here we are in our environment. Again, I'm not sure why it's giving an error. There are no errors. If we just sort of start this right now, see what we've got. So I removed that other girl model, and I also uncapped the frame rate. So we can see frame rate's pretty good. All right, so now what I want to do is I want to work on the mesh factory so that I can append models, as I was describing before. So I'll just close this down and I'll look at the mesh factory header. Okay, great. So we can make meshes, and I'm just going to change this so that, just change the name. There we go. Okay, and I'm also going to split this mesh function down into a few extra bits, just because it was getting a bit big. So the tasks involved are, first of all, we're going to open up the file, read through the file, and just count up the number of lines that we'll have to reserve. And then separate to that, we're going to read through the file and actually read in the data, so append in to these vectors here. All right, so this stuff is all fine. I'm just going to make a little modification down here. So imagine that we have loaded in some file already, and then we go to load in the next file. When we look through its OBJ file, its face lines will have some little descriptions describing which V's, VT's, and VN's should be referenced for that face. But if we don't know how many of these things we've already loaded, we will not be able to offset that index correctly. And, you know, when we load object B, model B, it will start to accidentally refer to the points in model A, if that makes sense. So what I'm going to do is every time after I load a model, I'm going to just keep track of how many of these things were actually loaded in. Okay, and with that done, we can now have a look at the source file. Okay, I'm going to start from the top. So the first function here is the start obj mesh. And this isn't strictly necessary, but why not? What I'm going to do is just clear any state that we would use. So this is basically a sort of state machine. It has some stuff that it remembers. We're just going to clear that all out. Okay, excellent. And now we have this make cube mesh. Sorry, what am I thinking? Make. Now this stuff is fine, but then down below we have this part where we make a VAO and VBO. I'm actually going to get rid of that because this model, we just want to generate the data basically, and then all the other stuff, like this model could be thrown in with a whole bunch of other models. We don't necessarily want to make stuff just yet. Okay, great. Now I'm going to have a look at this OBJ mesh. Okay, so what we can see here is that this stuff is sort of what I wanted to do, earlier with reserving space. So I'm actually going to grab all of this first section, so the first time we open the file, and I'll make that its own function. Now the question is, the question is, as we keep loading in more models, how are we going to reserve the space to take into account the stuff that's already been loaded? It's actually not too bad. What we can do is simply read off the amount of elements that we currently have there and take that into account. Just like that. And what I'm going to do is write down here, this is all fine. Instead of just increasing by this, I'm going to actually do this calculation at the point here. So we know how many triangles we're appending. We know the number of floats per triangle. So we'll just increase at this point. Okay, great. That is done. So yeah, as you can see, we just reserve the space. And then let's go ahead and read the file. So for reading the file, I'll grab all this stuff down here, right up until we close the file. Okay, I think that's fine. So close that down. And then these ones are fine. We're just loading in vectors. That's all good. Reading the face, yeah, take those points, make a triangle. Okay, now when it comes down here to reading the corners, this is where we need to take into account the number of things which have already been loaded. So right in here, when we're looking at V, we need to take, yeah, the number of vertices which have already been loaded. So I know I keep explaining this, but I'll just go through it once more. So we load model A, for instance, and model A could have, vertex 0, vertex 1, vertex 2. But then we go to load model B will also say vertex 0, vertex 1, vertex 2. So we need to offset that by adding the amount of vertices which have already been loaded by previous models. It's actually surprising that there's no more tricks involved there. Anyway, so I'll just go ahead and do the same thing down here. And we should be good. Okay, I'm happy with that. So we can minimize that. Now this last part, where we go ahead and make the VAO, VBO, all of that, that is really building the mesh. So we can just grab all of that. Just double checking. I think that's fine. Now, I think there's something. I'll just quickly double check this. Go back here. Oh, these should be... Oh, no, they're fine. Oh, okay. Great. So, that, unless I've made any mistakes, is the basic functionality. So we'll just go over to the render system because that's the stuff that's actually going to need to work with this. And I've split the render system into two different functions. One to build models, one to build geometry. We'll start off with the models. So if we go in here, and then sort of minimize this. Okay, right. So I'm just going to neaten this up a little bit. So I'll get this out of the way. While I'm at it, okay, before I get into actually loading this, I know this must be all over the place, but I'm going to simplify this a little bit. So remember I was saying that now instead of a whole bunch of models, I'm just going to have one model for every animation. So again, we have each object has a bunch of animations, and an animation is really a big model that holds all of the frames. Do the same thing over here. Now I think the rest is fine, but I am going to have to modify the deletion, the destructor, because what that's doing, I don't know why IntelliSense just stopped working. I don't know. But when we get here, okay, so we look through the VAOs, and that'll be looking through each animation, which is a set of things. And then inside there, we've got, now we're actually looking at the underlying VAO, and we can just go ahead and delete it. And same thing over here. We're not dealing with a set of buffers, we're dealing with a single buffer. Okay, I think that's fine. So close that down. All right. Right, back to business. In the case of the box, it's not super exciting because the box is not animated, but this is how we'll be using this thing. So we start off by initializing the factory, then we throw a mesh at it, and then we tell it to build that. Again, here, just one thing, but okay, let's have a look at Revy. So again, we tell the factory to start building, and then down below we're going to do some stuff. But then after we've done that, grab this. After we've done that, that's the point at which we're going to build the mesh. So right after this loop, build the mesh and remember everything basically. And in here we'll be appending that one at a time. So again, here's how it goes. We tell the factory to start working, and then for each of the 19 frames we load that in and throw it into that mega model. And then after we've done all the frames, then we build that big model and remember all the data. So build geometry, we'll get to that in a second. I just want to check that all of this is working. So what I'll do is just close this down, go to the update. And now here's what I'll do. I don't need to bind an individual frame. This thing will hold all the frames. But what I do need to do is calculate the offset into that. So if I take the frame times the vertex count, which will be the number of vertices in every frame. I know I'm repeating myself. Hopefully this makes sense. So we start at this offset, and this is the number of vertices we're going to draw. And that reminds me, I've missed something. Up above, when we loaded in Revy, that was 19 frames. So what I'm going to do is I'm going to take the vertex count divided by 19, based on the assumption, which I think is reasonable, that every animation frame has the same number of points. So let's just give this a run, see if there are any errors. There might be. Yeah, there totally are. Okay, there we go. Just a bit of re-labeling. Try that again. Okay, this is actually a valid error here, not a fake error. So we look through our VBOs, object type and animation, looping through there, and then the each individual VBO will be inside animations. Okay, this must be a very exciting video, but really we're just debugging. I mean, if you have ever played, that's not great. If you've ever played bumper cars, that's how I debug. I change a little thing, then I let the computer do the thinking for me. So then the question is, why is that not animating? Okay, so I think I found it. I think it's this bit here. So we go ahead and read the file, but I'm forgetting to register the number of things that we've loaded. So I'll go ahead and do that. Now let's give that a shot. Excellent, cool. So a little weird with the frame rate. It's jumping around a bit because I'm screen recording. When I do this at home, I get about 5,000 frames per second. But anyway, cool. So it is loaded. Great. Now remember, all these animation frames are in one model and we're just picking parts of the model to draw. That's all well and good. Now what I'm going to do is I'm going to make geometry using the same concept. And because there's a lot of typing involved, and I don't want to break my fingers, it's not that much fun to watch. I am going to copy paste this and then just talk through it. So in here we have this build geometry. In this build geometry, I'm going to do something very similar to what I did above. Okay, there's a whole bunch of code. So let me just make this a bit clearer. So just the same as before, we have our factories that we're going to use, and we specify we're loading geometry stuff with no animation. Then we start the process. And then note that we're now appending a whole bunch of models, a whole bunch of them. And we're sometimes appending the same model multiple times, but we're pre-baking the pre-transform that we're going to apply to each of these things, right? So here's a wall, here's another wall, but with a different pre-baked transform. So when we go to draw this, we don't actually need to pass any special data. It'll just draw where it should be because it's all pre-calculated. So we append all of that, then we build it and register that. And then we go ahead and make a texture. In this case, I'm just going to go with the paper texture. Why not? So let me just close this and we'll get to rendering that. Now, this is a special reserved thing because we know that our level has our geometry and that's not going to change. It's static. So we can actually, well, for now, I'm going to hard code that draw call. Okay, so here's the process. First of all, the model matrix, super simple, just the identity. In other words, no extra transform. It's already pre-computed. I must have forgotten to define this. No problem. No problem. I'll just go over to config and add in that geometry. Okay, great. Don't know what's going on with those include errors. Okay, so right, so we know exactly which texture we're using, and we know exactly which model we're going to load. Start from the start, and we'll do the whole thing. Fingers crossed, we should be seeing a world around us. All right, give that another go. Okay. Some slight changes will need to be made. Let's do that now. Oh yeah, everything's loaded. So first of all, Revy can probably come up a little bit, and then the projection matrix needs to be looking further away. So I'll just go, this is a lot of fun. I'll just go build models. Where's Revy? Yep. Bring the model up a little bit, and then to the controller. Right here in the, where are we? Set up OpenGL, I think. Okay. Here we go, projection matrix. I'll just set it out to a distance of 50. There we go. Okay. So Revy's running, we got trees and an environment around us. And all this stuff is being done with a single draw call, which is good. That's good. And as you can see, performance is about the same, or maybe better. Okay, don't want to jinx it. So, this is fine, but clearly these bits of geometry should have their own textures. Doesn't do much good to have them all colored the same. Now we could make what's called a texture atlas, where we stitch bits of texture onto regions of one big texture, but I had issues getting that to work. I think STB image resize should be in the trash where it belongs. It didn't work in my case. So what I found instead was image arrays. So I'll have a talk through that. So clearly I misspoke a little bit when I said it would be, well, actually, no, it is simple, but there's a little bit more involved. Let's say that we're looking at animation. Yeah, no worries. One texture is going to work for every animation frame. But if we're looking at geometry, these things might have individual textures. So then the next question is, how do we handle that? And well, the solution basically is to do the same thing. Now there's something called image array layers. And what that is basically a collection of textures. So imagine an object, it's treated like one texture, but it actually has a whole bunch of different images slotted together. So what we can do is we can sample, we can read from any of these textures, we can load data into any of these textures, and there we have it, image layers. So with that in mind, I'm going to use the same technique. I'm going to have a texture factory. I'm going to have some sort of command to tell it to start listening to my input. Then I'm going to basically append, but load a texture into a specific position, and then tell it to build that texture and give it back to me. Now, the only thing is, before we were using for texture coordinates vec2s, they were UV form. Now I'm going to use vec3s, and they're of the form UV, just like before, and then the individual layer of the texture that we want to access. Now, again, what are the use cases for this? Well, one use case is that, remember, we loaded in a whole bunch of static geometry, and each of those models might have their own texture. And so what we could do is load in a whole bunch of this and say, this is the geometry. And then when we draw, just go, hey, bind the geometry textures, do that bind call once, and then draw everything we need. And in the same token, we also have a bunch of models in our world for other things. And so we can create another one of these image arrays and call that, hey, that's all our model textures. So again, if we draw 10 models instead of binding 10 different textures, we just have one bind call. Anyway, so that's the gist of it. Let's see it in action. All right, so on to the business of converting this. I guess we'll start with the shader. So I'll just close all of this down, open up the shaders, and we'll start with the vertex shader. Now, instead of a vec2, we're now also tracking the image layer, so that's a vec3, but nothing has to change here. It's actually surprising how little changes. Now if we go to fragment, we'll take in our texture coordinate, and this sampler 2D is now a sampler 2D array, but then nothing has to change. You can sample from it just the same. Okay, great. So now what I'm going to do is I'm going to have a vec3 for the texture coordinates, not just a vec2. And to reflect that, I'm going to have to change my mesh factory a little bit. So if we head to the header, every time I append these models, I need to know which layer I'm appending to. In other words, to tell it which texture to use. So I've got that, and then I'm just going to set this to a variable. Okay, and that's fine. So, what's it? Oh, jeez, I hate this. Okay, so when we start a mesh, we want the current layer to be reset, just in case. Why not? But then, when we append any of these things, we want to set that internal variable. So for this case, actually, I guess we don't need that. I'll show you why in a second. Right down here. Okay, now back up top where we were defining this vertex data. I'm actually going to copy paste this in because it's not that exciting and it's a small change. Right, but here for these vertices, I'm going to replace them with this. So if we look here, we have X, Y, Z, then here U and V, and then the normal. If I change it to this, then we have U and V plus the layer. So this is the vec3, which is the texture coordinate. That's it. That's the only difference. And not much changes here either. As a matter of fact, the only other places where it changes are right down here, read corner. At this point, we can push the layer as a third component to the texture coordinate. And then when we go to build the mesh, we'll need to use a different layout for the attributes. Right, so build obj mesh. Well, stride will now have a vec3, vec3, vec3. So 9 floats, 9 times 4 bytes, 36. So we now have a stride of 36 for all of our attributes. And the offset here will be 24 bytes because we have 12 bytes per attribute. But yeah, I mean, nothing changes. Very little changes. Also down here where we go vertex count, that will need to be size divided by 9. And when we reserve space and we want to work things out, here we have 3 points per triangle and now 9 floats per point. But yeah, that's it. So what I'll do is I'll just modify this so that it's still working. I'll go over to the factory. No, not the factory, the render system. And here when I build the models, we'll say that the cube mesh is layer 0 and Revi is layer 1. And then when we go to the geometry, things will be a little bit different. So in the geometry, what do we have? We have the ground. Okay, let's say that the ground is layer 0. The wall objects are all going to be layer 1. Those corner pieces are layer 0. You can see where I'm going with this. Sorry, layer 2. And finally, the trees are going to be layer 3. This is just so that later on when we draw them, they can recover their appropriate textures. Right, so now I'm going to go to the texture factory and modify that. I mean, right now it's very simple. Let's fix that up. Nice and minimal. Hopefully this makes sense. Oh, something I forgot. We should be declaring how many layers to make at the start. Yeah, so we'll say like, hey, make a texture array. I want it to have 10 layers. And then bit by bit, we'll say, hey, throw in this one, this one, this one. Cool, so we'll just implement those functions. All right, so let's get to that in a second. Go through the usual process of creating and binding the texture. Make sure to bind it as a 2D array because that's what it is. And now I'm going to allocate some storage for that. I allocate that as if it was a 3D texture because essentially that's what it is. So here we have the target, which is 2D array, then the number of levels, 1 in this case, and then the internal format, which is RGBA, and the width and the height. So the one constraint on this is that all textures need to be the same dimensions. In this case, I went through my image folder, I resized everything to 1024 by 1024, but just bear that in mind. And now this depth argument is the number of layers that we want to allocate. So think of it as this will allocate, 7 slices of these textures in one go. Right, or whatever your number is. So we've got that, and then I'm gonna, load. Okay, now the difference here is I'm going to be doing, we go GL text subimage 3D. Okay, so I'm talking to myself. Okay, we load to an array, and then the next argument is, does it say? Yeah, it does. Okay, so the levels, we're loading to the base level, which is 0. Then we have the X, Y, and Z offset. So the X and Y offsets are going to be 0, of course. Then the Z offset is which layer we're loading to. So for that, we'll just put in the appropriate layer. Then we don't need to specify any formats, or we don't need to specify an internal format because that's already been declared in the storage statement above. All right, so then we have the width, the height, and the depth, which in this case is 1, because this layer is going to be one layer. I hope that makes sense. Then we have the format from the file. And that's unsigned byte. Okay, talking to myself again. Righty, that is fine. And why not? I'll just do the sampler configuration before returning it. Now, I think that's fine. This is all just going to have to change to 2D array. And we can actually get MIB maps in 2D arrays, which is pretty good. But I'm also going to have to add another wrapping case, and that's R. So in all dimensions, it's just going to wrap around. I think that's fine. So just close that down, and then we'll work with that. So we'll go to our render system. Oh, and there's another thing I forgot, and that's how we're going to deal with these textures. So instead of a whole bunch of them, I'm actually just going to have one for each batch. So I'm just going to have a vector of those, and we're actually just going to have 2, because we'll have one image array for everything in the static geometry, and then we'll have another image array for each where each layer is an individual object in the scene. So hopefully you can see we are improving, not deproving, not unimproving our engine as we step through it. Anyway, so that being as it is, we'll just go, I guess first up, all right, I'll do this here. So in the constructor, we will, why is IntelliSense not working? Anyway, we know ahead of time that we're going to have 2 textures, so let's just build that. Now, when we go to destroy stuff, we don't even need to loop. We can just destroy both textures in one go. Cool. I really like how this is getting simpler with more iterations, but onto the models. So we're going to have some issues here. Let's go down. Okay, so I'm just going to copy out all this stuff with textures and just deal with the textures right down here at the bottom. Okay, so I'm going to start an array with 2 layers. I'm going to add the paper as layer 0, Revy as layer 1, and then I'll read that back. Okay, so I'll close that down, and then I'll deal with the geometry. So for the geometry, where have I put it? This paper stuff, yeah, we'll get rid of that. Just copy paste it. All right, so again, we start a texture array with 4 layers. We load in each of those things that we need, and then save the created texture into the array. I flip these orders around because I'm going to draw the geometry first and then all the objects. it really doesn't matter. So then when I go to update, I'll just bind this as 2D array, and I'll just bind textures 0 will be the geometry. And then when it comes time to draw everything else, bind texture 1. And if I can find this, we do not need this bit here. I mean, does that seem cool or what? Maybe I'm just blown away by my own stuff until I hit play, in which case I'll find an error. Yeah. Okay. Let's investigate. All right. Okay, I forgot to... So this should be a vec3 that we're outputting. Okay. I think that's fine. Now look at that. How cool is that? We've got all our geometry. It all works. The frame rate is not bad. It's roughly at least double this frame rate when I'm not screen recording. Not that it matters. I mean, I'm just blown away that we've got all this stuff and it's just one draw call for all that. Except for, obviously, you know what I mean. But yeah, there we have it. Anyway, I know this video was a little dry, but at least from an engine design perspective, I hope you can appreciate the fun that goes into building these things. Okay, that'll be it for today. I hope you had fun, hope you learned something, and I'll see you again next time. Bye.